Bockscar.
As the second week of August began, the pressure on the 509th Composite Group intensified. The weather over Japan was deteriorating, with a massive typhoon system threatening to ground all bomber operations for a week. The military brass in Washington, particularly General Leslie Groves, the head of the Manhattan Project, wanted the second bomb dropped immediately to maintain the psychological shock and awe. The schedule was accelerated. The plutonium core, which had been delivered to Tinian, was carefully inserted into the high-explosive sphere of Fat Man. The weapon was loaded into the bomb bay of a B-29 named Bockscar, commanded by Major Charles Sweeney. The mission was briefed, the flight plans were drawn, and the complex arming procedures were finalized. The stage was set for a mission that would be plagued by mechanical failures, weather anomalies, and fuel shortages from the very moment the engines were primed. The weapon was armed, the target list was finalized, and a B-29 named Bockscar was being fueled on the tarmac, ready to deliver a second sun to a city that had no idea it was in the crosshairs. Major Charles Sweeney sat in the pilot seat of Bockscar on the sweltering tarmac of Tinian's North Field, staring at a mechanical reality that would have scrubbed any standard combat mission. During the pre-flight checks in the early hours of August 9th, his flight engineer, Master Sergeant John Kuharek, discovered a catastrophic issue with the fuel transfer system. The B-29 Superfortress was equipped with a bomb bay reserve tank holding 600 gallons of high-octane aviation fuel, designed to give the heavy bomber the necessary legs to make the round trip to the Japanese home islands and back. The transfer pump that was supposed to feed that reserve fuel into the main engine lines was dead. It was not just malfunctioning, it was completely inoperable. This meant Bockscar was carrying an extra 3,600 pounds of dead weight that it could not burn, while simultaneously being robbed of the critical fuel required for the return flight. In standard operating procedure, you do not take off in a crippled aircraft, especially not one loaded with an experimental 10,800-pound plutonium weapon. But this was not a standard mission. General Leslie Groves and the Manhattan Project command structure had made it abundantly clear that the weather window over Japan was closing fast, and the second psychological hammer blow had to fall immediately. Sweeney made the tactical call to fly the crippled bird. Would you risk a multi-billion-dollar experimental nuclear device and the lives of your entire crew by launching a heavy bomber with a dead fuel transfer pump into hostile airspace? Most commanders would have aborted, but Sweeney understood that in total war, the mission dictates the acceptable level of risk. Taking off with a faulty aircraft under extreme strategic pressure is not without precedent. You only have to look back to April 1942, when Lieutenant Colonel Jimmy Doolittle launched his squadron of B-25 Mitchell bombers off the deck of the USS Hornet hours ahead of schedule, knowing they lacked the fuel to safely reach their recovery airfields in China. Doolittle launched because a Japanese picket boat had spotted the fleet, and waiting meant losing the element of surprise, or losing the carrier. Sweeney launched because the strategic momentum of the atomic campaign could not be stalled by a broken pump. At 3:47 a.m., Bockscar lumbered down the coral runway of Tinian. The aircraft was massively overweight. The four Wright R3350 engines screamed at maximum manifold pressure, burning through precious fuel just to get the beast airborne. Sweeney held the nose down, eating up every inch of the 8,500-foot runway, pulling the aircraft into the dark sky mere feet before the runway ended at the ocean cliffs. Once airborne, the brutal reality of the mission profile set in. The flight to Japan was not a straight shot. To avoid draining the batteries and overworking the electrical systems, the bomb was kept in a relatively dormant state during takeoff. It was up to the weaponeer, Navy Commander Frederick Ashworth, to enter the unpressurized bomb bay during the flight to physically arm Fat Man. Imagine the cold, calculating nerve required to crawl into a freezing, deafening bomb bay at altitude, holding a flashlight in your teeth to swap out the green safety plugs for the red arming plugs on a device capable of vaporizing a city. Ashworth had to manually connect the firing circuits to the 32 explosive lenses surrounding the plutonium core. One static discharge, one fumble of the hands, and the B-29 would be instantly converted into a flash of gamma radiation over the Pacific. The arming sequence was completed flawlessly, but the friction of the mission was just beginning. The tactical plan required Bockscar to rendezvous with two other B-29s over Yakushima Island off the southern coast of Kyushu before proceeding to the primary target. One aircraft, the Great Artiste, was loaded with blast measurement instruments. The other, the Big Stink, was carrying photographic equipment to document the strike. The rendezvous altitude was set at 31,000 feet. Sweeney arrived at the designated waypoint and linked up with the Great Artiste, but the Big Stink was nowhere to be found. Strict radio silence was enforced to avoid alerting Japanese early warning radar networks. Sweeney began to orbit Yakushima, burning aviation fuel at a terrifying rate of roughly 400 gallons an hour. The mission parameters dictated a maximum waiting period of 15 minutes at the rendezvous point. Sweeney, hoping to execute the mission exactly as planned with the photographic ship present, orbited for a grueling 45 minutes. This was a critical tactical error forced by the fog of war. Those 45 minutes of loitering burned thousands of pounds of fuel that Bockscar desperately needed to compensate for the trapped reserve tank. The missing B-29 was actually flying at a higher altitude, running a slightly different flight pattern, a miscommunication that almost doomed the entire operation. Realizing they were bleeding fuel and daylight, Sweeney and Ashworth made the call to break orbit and proceed to the primary target with only 2 aircraft. The target was the city of Kokura, the site of one of the largest and most vital military arsenals in the Japanese Empire. The Kokura Arsenal was a sprawling industrial complex, a massive footprint of steel mills, vehicle plants, and weapons factories. It was the exact type of target strategic bombing was designed to erase. But as Bockscar approached the initial point for the bomb run, the environmental conditions shifted dramatically. The weather over Kokura was supposed to be clear, but the city was obscured by a thick, impenetrable haze. This was not just natural cloud cover. The day before, American B-29s had firebombed the neighboring city of Yawata, the Pittsburgh of Japan. The massive fires from the Yawata steelworks were still burning out of control, and the prevailing winds had pushed a massive curtain of black smoke directly over Kokura. Furthermore, some historical accounts suggest that Japanese workers at a coal tar plant in Kokura deliberately ignited barrels of coal tar to create a smokescreen upon hearing the air raid sirens. This environmental interference created a massive tactical dilemma. The absolute unbending orders from General Groves and the Strategic Air Forces Command were that the atomic bomb must be dropped visually. The bombardier had to positively identify the target through the Norden bomb site. Radar bombing, using the onboard AN/APQ-7 Eagle system, was strictly prohibited for the atomic drops. The military brass did not want to risk a radar anomaly, causing the 10,000-pound weapon to detonate harmlessly over a rice paddy or the ocean. They needed maximum destruction on a verified military-industrial complex. The bombardier on Bockscar, Captain Kermit Behan, peered through the optics of the Norden bomb site, searching for the aiming point. The Norden was an incredibly advanced analog computer for its time. Once the bombardier locked onto the target, the bomb site actually took control of the aircraft's autopilot, making minute adjustments to airspeed and heading to ensure a perfect ballistic trajectory. But the Norden was useless if the bombardier could not see the ground. Sweeney flew Bockscar over Kokura not once, not twice, but 3 separate times. For nearly an hour, the heavy bomber crisscrossed the flak-filled skies above the primary target. The Japanese defenders were not idle. Heavy 120mm Type 10 anti-aircraft guns began to track the American bombers. Flak bursts started blossoming at 30,000 feet, inching closer to Bockscar's flight path. More alarmingly, the radio operator intercepted Japanese communications, indicating that squadrons of Nakajima Ki-45 Torii twin-engine interceptors were scrambling from nearby airfields to hunt them down. The situation was deteriorating rapidly. The fuel gauges were dropping toward the red line. The trapped 600 gallons in the bomb bay mocked the crew. How often does a simple shift in the wind dictate the survival of hundreds of thousands of people? Similarly, the smoke and haze over Kokura on the morning of August 9, 1945, acted as a divine shield for the city. After 3 futile bomb runs, taking anti-aircraft fire, and with fuel reaching a critical state, Sweeney and Ashworth held a rapid conference on the intercom. They could not stay over Kokura. They did not have the fuel to return to Tinian. They barely had enough fuel to reach the emergency landing strip on Okinawa. They had to divert to the secondary target, drop the weapon, and pray they could glide the B-29 into Okinawa before the engines starved. The secondary target was Nagasaki. Bockscar banked southwest, leaving Kokura behind, and initiated a desperate sprint toward the western coast of Kyushu. Nagasaki was a vital military port and industrial center, but its geography made it a terrible target for an atomic weapon. Unlike the flat delta of Hiroshima, which allowed the blast wave to expand uniformly and obliterate everything in its path, Nagasaki was built in a series of deep ravines and valleys, segmented by steep hills and mountains. The primary aiming point was the massive Mitsubishi Steel and Arms Works, located in the Urakami Valley. If the bomb detonated perfectly over the valley, the surrounding hills would actually contain and channel the blast, intensifying the destruction within that specific corridor, but protecting the rest of the city. As Bockscar approached Nagasaki at 10:50 a.m., the crew was met with another crushing disappointment. The weather front had moved in, and Nagasaki was covered by 70 to 80% cloud cover. The visual aiming point was completely obscured. Sweeney's fuel situation had transitioned from critical to catastrophic. They were running on fumes. There was no time for multiple bomb runs. There was barely enough time for one pass. If they did not drop the bomb right then and there, they would be forced to ditch a live nuclear weapon into the East China Sea, or worse, crash land with it on Okinawa. Commander Ashworth, the ranking naval officer and weaponeer, made a command decision that directly violated his standing orders from the President of the United States. He authorized a radar approach. When the rigid rules of engagement written by men sitting in air-conditioned offices in Washington collide with the brutal, immediate reality of a blinking fuel gauge in a combat zone, who makes the call? The tactical commander on the ground, or in this case, in the air, must adapt or die. Ashworth refused to let rigid ROE cost them the mission. He ordered the radar operator to guide them in. The B-29 leveled out at 31,000 feet. The bomb bay doors snapped open, exposing Fat Man to the freezing thin air. The radar operator was calling out the final approach coordinates. It was going to be a blind drop. But at 11:01 a.m., mere seconds before the release point, a miracle occurred. Bombardier Kermit Behan, staring intently through the eyepiece of the Norden bomb site, saw a small, fleeting break in the cloud deck. Through that temporary hole, he spotted the unmistakable geometry of a stadium track in the Urakami Valley, located roughly 1.5 miles north of the intended aiming point. It was close enough. Behan shouted into the intercom, "I've got it!" He instantly took control of the drop sequence, aligning the crosshairs on the stadium. At exactly 11:02 a.m., the restraining hooks released. The 10,800-pound aerodynamic nightmare plummeted from the belly of Bockscar. The sudden loss of 5 tons of weight caused the massive B-29 to surge violently upward, gaining hundreds of feet of altitude in seconds. Sweeney immediately threw the aircraft into a brutal 60-degree diving turn. This was a highly practiced, evasive maneuver designed to put maximum distance between the fragile aluminium skin of the bomber and the epicenter of the impending nuclear flash. High above the carnage, Major Charles Sweeney was fighting for the survival of his aircraft and his crew. The B-29 Bockscar was executing a diving high-G turn to escape the expanding shockwave. The first wave hit them like a physical blow, violently tossing the massive bomber upward. A second wave, reflected from the ground, slammed into them moments later. Then came a third, weaker wave. Looking back, the crew witnessed a terrifying, boiling pillar of radioactive smoke and debris rising at a rate of thousands of feet per minute. A mushroom cloud that would eventually punch into the stratosphere, reaching an altitude of over 60,000 feet. But Sweeney did not have the luxury of staring at the apocalypse. The fuel gauges were hovering near zero. The trapped reserve tank in the bomb bay was completely useless, and the 4 massive Wright engines were starving for high-octane fuel. The return trip to Tinian was mathematically impossible. The only viable option was a desperate sprint to the recently captured island of Okinawa, located hundreds of miles to the south. This is where the grim reality of military logistics violently intersects with tactical execution. You can have the most advanced weapon system on the planet, but if you do not have the fuel to bring the delivery platform home, you have failed the mission. The flight to Okinawa was an exercise in extreme fuel conservation. Sweeney pulled back the throttles, lowered the RPMs, and leaned out the fuel mixture to the absolute ragged edge of stalling the engines. The bomber descended at a shallow angle, trading altitude for distance, gliding as much as flying. As they approached Yonton Airfield on Okinawa, the situation deteriorated from critical to an absolute emergency. Sweeney tried to raise the control tower on the radio to declare an emergency landing, but the radio was dead. The airfield below was chaotic, crowded with aircraft, and completely unaware that a crippled bomber carrying the crew that just dropped the second atomic bomb was plummeting toward them. With no radio contact, Sweeney ordered the crew to fire every emergency flare they had from the flare gun. Red, green, and yellow flares streaked into the sky, a universal signal of a catastrophic emergency. Sweeney did not have enough fuel to circle the airfield or make a standard approach. He had to drop the heavy bomber onto the runway on the first try, coming in fast and hot. As Bockscar crossed the threshold of the runway, the number 2 engine sputtered and died, completely out of fuel. Moments later, the number 1 engine quit. The massive B-29 slammed onto the tarmac, bouncing heavily. Sweeney stomped on the brakes, but the aircraft was carrying too much speed. To make matters worse, the loss of engine power meant a loss of hydraulic pressure. The brakes were fading. The The bomber hurtled down the runway, heading straight for a line of parked B-24 Liberator bombers at the far end. Sweeney ordered the engines to be thrown into reverse pitch, a violent maneuver that strained the airframe to its limits. The remaining two engines roared, fighting the forward momentum. Bockscar finally shuddered to a halt, nose down, just feet away from the parked aircraft. When the crash crews arrived to tow the bomber off the active runway, they discovered that the fuel tanks were completely bone dry. The aircraft had literally landed on vapor.